Hello class, this would be the video for multiple dosing assignment. All assignment you will see a question like this. Here that a drug follows one compartmental model and then clearance. This is population values that the population values, that means in a country or in a state, the people usually has a clearance of this drug. This clearance 46 and volume distribution V, and it has a therapeutic range. That means here you have, when you say therapeutic range, here you have a C mean and C mean. This would be your Cmax. So now my problem is asking to calculate number of parameters. One of the first is plasma half-life. To calculate plasma half-life, we need K, and to calculate K we have to use K is equal to CL by V, and we have CL in milliliter per minute and V is in liter. So this you need to convert first to liter per hour, and when you after you convert the liter per hour, your answer would be like 46.4 milliliter per minute divided by 63.4 liter. You see, if you convert, I think I showed in the class, you will have a K of, I think your K would be 0.044. So this would be okay, and I hope you know how to calculate milliliter per minute to liter per hour, and this would be in hour. So once you know the K, you can easily calculate half-life. So how you calculate half-life? Let's clean this. You can calculate half-life. Your K, so T half is equal to 0.693 divided by 0.044. It should give you a T half of, let's go back to here, 0.693 divided by 0.044. It should give you T half of 15 hour 0.78 hour, 15.78 hours. So this is your T half. Now you have to calculate my accumulation factor. To calculate accumulation factor, you have to use this equation. RACC is equal to 1 by 1 minus e to the negative k tau, and in this case we know what is K. K is equal to 0.044 per hour. This is 4, and tau, our tau is what? 24 hour. So if you calculate using this equation, it should give you an RSCC. Let's clean this. It will give you an RSCC of, I think it is going to be 1. To save time, I am not showing this time the calculation. 535. This is what the answer is. So you can make RSCC is equal to 1.54. I'm not using calculator because this saves time and video will be shorter, and I do not have to spend a lot of time in uploading these videos. And then maximum concentration after the first dose. In that case, we have to use Cmax 1 is equal to first dose by V. So our dose is, I think, 180 milligram, and our volume distribution is 63.4. So this should give you a value of 2.839. So this is for Cmax. And then to calculate Cmin, you have to use that Cmax, this Cmax. So Cmin is equal to Cmax times e to the k negative tau. So you know what is your Cmax? Cmax is 2.839 times e to the negative k. We have learned 0.044, and tau is 24 hours. So this should give you a value of 0.99 or 0. Could be. If you do the calculation, this value will give you, if you multiply 2.83 times e to the negative 0.044 times 24, it will give you a value of 0.989. You can make it 99, 0.99. So this is your Cmax. So your Cmax is going to be, this is your Cmin. Your Cmax is going to be 2.839 milligram per liter, and your Cmin is going to be 0.9896 milligram per liter. Then we have to calculate average steady state concentration. To calculate Cmin at steady state, we have calculated, in this would be the data for these two questions. Let's see. So we have Cmin, Cmax after first dose would be 2.839 milligram per liter, and Cmin is going to be 0.989 milligram per liter. Let's clean this up. So now we have to calculate Cmax at steady state. To calculate Cmax at steady state and Cmin at steady state, we need accumulation factor. So we have calculated earlier that accumulation factor using this equation. Our accumulation factor was our accumulation factor was 1.54. So here we will calculate Cmax at steady state. Cmax at steady state would be Cmax first times RA CC is equal to, what is the Cmax first? Our Cmax first was 2.84 times RSCG is 1.54. So this should give you a Cmax at steady state. I think it is 4.37. Again, I am not doing using calculator because it is taking long time, and then video becomes very large. It's hard to post. Then Cmin at steady state. So we have to use this equation. Cmin at steady state is equal to Cmin first times RSCC. So what was our Cmin? This was our Cmin. 0.989 times 1.54. It should give you 1.5. Cmin first 1.54. Let's see. It should give you 1.51. It makes little sense though. Just a minute. Okay, but it will give you something like 1.519. It could be 1.52. So now we have our Cmax at infinity, Cmin at infinity. That means we have let's write down those values here. We have Cmax at steady state is 4.35 milligram per liter, and Cmin at steady state is 1.519 milligram per liter. So now we have to calculate average at steady state concentration, which is C average. C average, to calculate C average, we cannot take the average of this. We cannot take we cannot do like 3.5 plus 1.52. Sorry, 1.52 divided by 2. This will give you an close number, but we have to take into consideration that exponential decline from Cmax to Cmin. For this reason, we have to use a little complex equation. Here is the equation we have to use. C average is equal to Cmax Cmin divided by natural log Cmax infinity and Cmin infinity. So using this equation, you can put what is your Cmax. If Cmax would be Cmax infinity is 4.35 minus Cmin is 1.52 divided by log 4.35 divided by 1.52. And if you work this out, so it's going to give you a C average concentration of this would be 2.693. So this is how you calculate C average. So your C average, for C average you calculate using this equation, and your C average is going to be 2.693 milligram per liter. Then time to reach 90%, which is very easy, is T half. If you remember, our T half was this one, 15.78 hour. So we know the time to reach 90% of the steady state would be 15. Here this is 15.78 times 3.3. This will give you time to reach, which is called is about 52.079 hour. So this is your, which is called TSS. So now your TSS, time to reach, is 52.079 hour. So if now it's a number of doses to reach 90%, we know that our time required 90% is 52. So, and the dose, what are we doing is we are administering the drug, I think it is every 24 hours. So you divide this hour 0.79 by 24. This will give you about 2.16. That means it is saying if you administer 2.16, it should achieve 2.16 doses. This is dose, number of doses. Then you should achieve 90% of steady state. But we cannot give 2.16 dose. So then we have to extend to 3 doses. But we cannot go down. If you go down, that would put the semin below the therapeutic level. That's why we have to use a higher dose. Our goal is to keep therapeutic, keep the dose within the therapeutic limit between semin and Cmax. And the degree of fluctuation between maximum minimum concentration is degree of fluctuation between maximum and minimum concentration. You can calculate using this equation. C max by C min. These are all infinity. So if you divide, it's going to be 4.37 milligram per liter by 1.5652 milligram per liter. So degree of fluctuation is going to be about 2.86. So this would be your degree of fluctuation, or I think it could be 870 based on the calculation. Now loading dose to reach steady state immediately. So what would be your loading dose? As we know, the loading dose to steady state immediately, dose is equal to what? Dose is equal to dose is equal to Cmax times V. So Cmax after first dose. So if we go to Cmax after first dose, what is our? So it is 4.37 Cmax at steady state, so 4.37 times volume of distribution, which is volume distribution is 63.4. So 4.34 times 63.4, which is about 275 275.79. so it is like 276. So and then it says please round to two significant digits, so we can convert it to 280. So we can convert it to 280. So this is what for the first set of calculation. So this is for the first set of calculation. Here then I will post in a little bit the other answer to other two problems. Here I posted something for you. It's a funny video here. Hello, so I'm going to go over this calculation again with you in a clean slate, so that you understand everything, which equation to use and what not to use to avoid confusion. So here we go. First you have to calculate T half, you must calculate K. to calculate k, you have to use that equation. K is equal to, first you calculate k is equal to CL by V, whatever you get, then you use T half is equal to 0.693 divided by K. And for RSCC you have to use this equation. You already know RSCC is equal to 1 negative K tau. This has to be tau. And then for Cmax, after first dose you have to calculate Cmax is equal to Cmax first divided by multiplied by RSCC. And to calculate Cmax first is Cmax, how we calculate Cmax first? Cmax first is nothing but dose divided by V. So, and to calculate Cmin, you have to maximum concentration at Cmax first. Oh, sorry, I messed up here again. Cmax first is nothing but dose divided by V, and Cmin first you have to calculate Cmax first e to the negative k tau. So you have to use here e to the negative k tau. So once you have calculated, you have to calculate Cmax steady state. I confused here. So in Cmax steady state you use RSCC. Cmax is equal to Cmax first times RSCC, and to calculate Cmin infinity, you calculate Cmax, you calculate Cmin first, Cmin first multiplied by RSCC, and then average steady state concentration. For average steady state concentration, use that equation. Average steady state concentration, C average is equal to C max minus C min divided by log, natural log, C max infinity by C min infinity. And to calculate time to reach steady state, you multiply T half with 3.3. This will give you time to reach a steady state. To calculate number of dose, you divide TSS divide by U tau, which is 24. This will give you number of dose to reach 90%. And the degree of fluctuation you have to calculate using degree of fluctuation in steady state. Use degree of fluctuation is degree of fluctuation you have to calculate using this equation. C max divided by C min infinity. And loading dose, to calculate loading dose you immediately, that means here you have to use dose, as you if the question is asking to calculate loading dose immediately, you have to use C max you have calculated at infinity times volume distribution. So I hope this helps. I'll post the other video sometimes later.